and we'll go ahead and get started. So these questions, I think they might all have been from the 2018 test. I don't remember. But these are the more recent ones, and you can see the combination of lab information in them, as well as like talking about various aspects of what a procedure might be. And granted, I just chunked out portions of these questions. But that's why we've only been focusing on questions from the last couple of years, because they have kind of changed their approach. But looking at this first one, they give you a giant equation at the top. So automatically, what are they telling you?
The mole ratio.
All right. So they gave you this, so you know you're going to have a mole ratio. All right. They will not provide you with a balanced chemical equation otherwise. Like, that is literally the point of it. So that's the first thing you see. And then the text of the question says they perform an experiment to determine the value of delta H for they tell you it's a redox reaction presented by that equation. Now, I only took the first part of the question. This portion where you actually calculate this is the second part of the question. And that's where the rest of the lab-based stuff comes in. So this is just the first part of the question. And remember, what I had said is that the way most questions are structured, they have designed some fairly easy to get points at the beginning of a question, and then kind of when they switch topics within a question. So this is all basically reaction stoichiometry stuff. But the next part of the question that would switch over to talking about heat and calorimetry and stuff also has at the beginning of that topic a very easy to get point, because they've designed the questions that way. So in every question, there are easy to get points followed by progressively harder points. So in theory, the very first question here on part A is designed to be an easy to get point. Determine the oxidation number of chlorine in NaOCl. So do that. And they do not require any work for this. This is literally write a number, and that's the point. So you should be able to easily assign 2 of those elements to figure out what the chlorine is. So what are you getting for the chlorine? But what do you know in that compound?
Na and O2.
I can barely hear you, Carl.
Na and O.
All right, and what is Na?
One plus.
Yep. Metals just take their normal charge. Nothing different there. And what do we know O is?
2 minus.
Yep. So what does that make chlorine have to be to make the plus and the minus cancel out?
1 plus.
Yep. And for oxidation numbers, we do put the sign first. So it is a +1. So the second part says calculate the number of grams of this needed to prepare 100 milliliters of this. So on your mole map, where are you starting?
With gram? No, you end at the end.
You're ending at grams, right?
The volume,
Yeah.
Volume of
the Na2S2O2.
3.
is that a solution or a gas?
Oh.
Solution.
Solution. So volume of solution. So we're going to go down to moles and then over to mass. So which number are you starting with?
5 milliliters.
No.
100 milliliters?
100 milliliters. Yeah. So that's the setup. Figure out what goes where. I'll be nice and give you the molar mass of the sodium thiosulfate to save you time.
Thanks.
Mm-hmm.
Ms. Baskin, can I read you my setup?
Yes.
Okay, so I have start with 100 milliliters, and then I have milliliters to liters, and then liters to moles, and then grams to moles, or moles to grams.
Yeah. So you then put in here 1,000 milliliters in 1 liter. And then what did you have in the next spot, numerator and denominator?
I have it blank because I wasn't sure what to put right here.
Now this is where you use the molarity in that spot.
Okay. Okay. So we have 5. Oh wait. Oh. 0.5
Uh-huh.
liter. Okay. Calculator.
Yeah. 0.5 over 1 liter. And then in the last spot is the molar mass, numerator or denominator?
Say it again.
In the very last spot here is molar mass, numerator or denominator?
Numerator.
Numerator. All right, and then how many sig figs should this answer have?
5.
3.
3.
Yay.
You are going to base it off this molarity here. That's 3. That is 5. 3 is smaller, so we'll go with 3. So to 3 sig figs, what is this answer?
7.91.
Is that what you guys got? 9-1?
Yes, that's what I got.
Okay. Yup. Okay, so in this question, they awarded essentially 1 point for doing that work using the molarity and the volume, and then they awarded another 1 point for using the molar mass and getting the correct final answer. So right there, that's 3 points altogether in those first 2 questions. And the next one, they give you this chart. And in general, if there's a data table anywhere, the data table is always used with any questions that follow it. So since the data table is here, it's clearly not going to be used in parts A and B. So that's something that's there to, you know, visually help you think about where do I use those numbers. You'll use those numbers in any of the questions down below. So I've got 3 different solutions with the concentration and a volume. And it says using the balanced equation for the reaction above and the information, determine what reactant is the limiting reactant and justify your answer. So are they specifically asking for a calculated value?
No.
No, they are not. They are not asking how many moles of something. They're not asking for a theoretical yield. They're just asking which of those 3 substances is the limiting reactant. So with that in mind, don't do more work than they ask for. So you don't have to go crazy here. Just provide what it is they're asking for. So think through, you can answer this question logically. You do not actually have to do a massive amount of calculation here.
Well, how would that work? Thinking it through logically.
Well, what can I figure out if I have concentration and volume?
Moles.
Moles. All right, with these 2 things, I can think about moles. Well, what do I notice about all of their concentration and volumes?
They're the same.
They're all the same, which means they all have the same moles to start with, right?
Mm-hmm. So then you look at the ratio.
So then you look at the ratio.
So the one that has nothing would be the limiting one, because there's less of it.
Well, you got to think about in a mole ratio, these numbers are in the denominator side. And they're not asking you for any specific thing, but these numbers, if you were to set up a mole ratio, these would be on the numerator side. So if you remember that the reactants are the denominators, who are you going to run out of first? The thing with the 1, the 2, or the 4?
NaOCl.
The 4.
The 4, right? So the answer is the NaOCl, and essentially equal number of moles to start.
But it takes 4 times as much.
All right. But 4 times as much NaOCl required. That is not how you spell required. Required to react. Done. You are mentioning the important part from the table here is the equal moles, and you are mentioning the mole ratio portion from the balanced equation, the coefficient. And that's what they said to do, is to use the balanced equation and the information in the table above. So as long as you've referenced both things they're asking for, then you've done exactly what it is they're looking for. Again, no calculation required.
Miss Baskin?
Yeah, Sean.
I had a quick question, just jumping back before we move on to the next one. For the oxidation number, that's based on the column, or that, so like, is that like if you ask the oxidation number of like anything in one column, it's gonna be the same, or like, because I know I was stuck on that one. I was like, so can you just like review oxidation numbers really quickly?
Oh, that's what we did on Friday. So you can do that for metals. For metals, their oxidation number is the same as the charge. So that's how we knew that the sodium was +1. Oxygen is always -2. And then pretty
Okay.
much any other non-metal, you're going to have to figure out.
Okay.
So since this entire compound, NaOCl, did not have a charge, we know that overall the oxidation numbers have to cancel out. So if I have a -2 from the oxygen, that means I must have a +2 amount to cancel it out. But only +1 came from the sodium, so the chlorine also had to provide a +1.
Okay.
Yeah.
Thank you.
Okay, so let's move on to the next question. So this was the second question, and again, this is the very beginning. And I put this question in here not because you're going to be asked to do something like this, because we know you're not going to be asked to draw a particle diagram, but it is useful to always look at and be able to interpret. So again, they give you a balanced equation. So anytime it's a balanced equation, that means think mole ratio. All right, so it's somewhere in the problem. You're going to have to think through the mole ratio. So one of the reactions in the investigation requires an equal molar of NO and NO2, blah, blah, blah. Okay, so this is the particle level representation of the equal molar mixture of this at the equal molar of this in the flask at the completion of the reaction between this and this is shown below in the box on the right. So in the box on the left, draw the particle level representation of the reactant mixture of this that would yield the product mixture on the right. And then it says filled in circles are nitrogens, open circles are oxygens. So basically, what it's asking you to do is to take this reaction backwards, knowing that you have to make sure, so you need to count the circles, all right? Don't violate law of conservation of matter. You have to have, if a circle existed on the right, it had to exist on the left. Just make sure you know what it belongs to. So the only things you are allowed to have on the left are what, according to the balanced equation at the top?
NOs and O's, or NO2s.
You can have NOs, and what else?
O2s.
O2s. That's all you can have. So you should notice that I already have some what? And in my product side, what do I have some of that must have just been left over?
NO.
You have NOs left over, which means you should just immediately redraw those on the left because they nothing happened to them. So this guy, this guy, this guy, and this guy were present on both sides. All right, so I know I can draw that one. I can draw that one. I can draw that one. And I can draw that one. They were there both times. So it's these other four NO2 particles, which were the product of this reaction. Those are the ones I need to reverse. So out of these four things, how many NO particles am I going to get?
4.
4. I have 4 NO2s. So the only way nitrogen exists in this system, according to a problem at the top, is as NOs. So, okay. So an NO, an NO, an NO, and an NO. So that uses that, and that, and that, and that. So what do I have left?
Oh.
4 O's.
4 O's.
And how are they going to exist as reactants?
O2.
SO2.
Together. So
Together.
2 pairs of O2.
Yep. So once you think you've got it, then recount. So I have 1, 2, 3, 4, 5, 6, 7, 8 shaded circles. 1, 2, 3, 4, 5, 6, 7, 8 shaded circles. And then count your opens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So again, they're not going to ask you to draw, but they, hands down, there is going to be some sort of particle representation somewhere. Just remember to count and that you have to maintain conservation of matter. You have to make sure you know what's going on with your circles and everything. So that's that one. I just wanted to go over that. Then the last question. All right. This is also from 2018. These are the first 3 questions out of 2018. So this is not the very beginning. This is kind of like where they've mashed together several topics. And you can see that this is starting off with some text and then parts D and E and F, G, H, I. So this is the last portion of the question. Just remember, there are, in theory, easy points to get when you transition in the topic. So it says a student obtains a solution that contains an unknown concentration of Fe2+. To determine the concentration, the student titrates a sample of the unknown solution with permanganate, MnO4, which converts this Fe2+ to Fe3+ as represented in the equation. So from that text, I want you to go ahead and think about what we know of from titration. So they're describing a titration experiment. So in a titration experiment, you know, we've got our burette and we've got our flask. So between the substances mentioned, who's in the flask and who's in the burette?
Aren't you adding the NMO4 so it's in the burette?
Yes, MnO4 is in my burette, which means that down here is my Fe2+. Okay, so they haven't specifically asked for that, but it is helpful to, when they talk about a titration, to either make a quick actual physical sketch or at least to stop and have a mental picture of, okay, so what is in what piece of equipment, because sometimes that can help you figure out what's going on. So they give me this big whole long equation and they say, write the balanced equation for the half reaction of just this. Okay. We didn't spend a whole lot of time on this, but essentially they're asking you to piece out this part and this part in its own separate equation, which is actually very, very easy. Because I'm literally going from Fe2+ to Fe3+. I'm balanced in terms of elements. Yes?
Oh, so that's it.
It is not it, because what is not
Well,
balanced?
well, you talk about it's easy.
It is
And
easy,
you
but
said
you need to only write one more thing in here. What is not balanced? What is not the same on each side?
The charge.
The charge.
Yeah.
We can only affect charge with electrons. So
okay.
which side needs an electron? Because these two numbers are only different by 1.
3+.
The 3+.
Oh.
An electron will pull the 3+ down to 2.
So you can just write +E.
Yes.
That is ghetto. That is not the chemistry
Yes, it is.
I know.
Uh-huh. And it's because they chopped off section 9 or unit 9 at the end where we do a lot more with half reactions. So it feels a little weird to just have this in here.
Plus E.
Because
So
normally we do these half reactions when we're talking about batteries, which is what's in part of unit 9. Because a battery is actually 2 half reactions that are separated, and it's the passing of the electrons that actually is the electricity. So
yeah,
it just seems
So
out of context right now.
if we saw another one of these per chance on the actual exam, would we like if we're doing? Is it just like if it was more than one, it would just be like plus 2E plus 3?
Yep.
Okay.
Yep. So, all right. So that's D. And then E says the student titrates a 10 milliliter sample of the solution. Okay, so that's 10 milliliters of that, 10.0 milliliters of that. Calculate the value of the, what does this bracket there mean? What are they asking for?
Molarity.
Concentration, molarity. In the solution, if it takes 17.48 milliliters of 0.0350 molar potassium permanganate to reach the equivalent point. So, first thing I want to point out, where is potassium in that balanced chemical equation at the top?
I was just looking for it.
There.
It's not there because it's a what?
A spectator.
It's a spectator, so we don't
It's
care about
not
it.
important.
All right, so
Irrelevant.
yeah, so by saying potassium permanganate, they're just saying the permanganate ion, MnO4 minus, like that's what that is.
Okay.
So this is just a stoichiometry problem. I have a volume, I have a molarity, and it's asking me for a concentration. I have a balanced chemical equation, which is going to let me do, it's asking me for this, and I've got this, so I know I'm going to stick a mole ratio in there. So let me scooch down a little bit to find some free room here. So what number do I start with?
The 17.48.
Yes.
Yeah.
So I'm going to start with the 17.48 milliliters of permanganate. And in my next stop, you can do the 1 liter over 1,000 milliliters, but you can also cheat and say that you can use the 1,000 milliliters at the bottom of your molarity. And basically just combine those two steps.
Wait, so that's on the numerator, that's moles?
Yeah.
The mole ratio.
And then next would be my mole ratio. So moles of permanganate and moles of the Fe2 plus. So what numbers go where?
1 is in the denominator and 5 is in the numerator.
Yep. So now I've canceled out moles of permanganate. So that's going to give me moles of iron. And then how do I get the concentration?
Put it over 1 liter.
Not 1 liter,
10 milliliters.
10 milliliters. But I do need to put that in liters.
So move the decimal place 3 to the left.
Yep.
So you can just, you don't have to, you just divide by the 0.010. You don't have to like, okay, yeah.
Correct, yeah. So when you stop and look at all of this, how many sig figs should your final concentration have?
4?
3.
Question mark?
3.
3.
The 10 milliliters is 3. The molarity of the permanganate is 3. The volume of permanganate is 4, but you go with the smaller.
Miss Baskin, where
Yes.
does this come from?
Where did the what?
The 5 come from?
The balanced chemical equation.
Got you.
Mm-hmm. All right, so what are you getting to 3 sig figs?
Wait, okay, so after we do the
I'm not
calculation
done.
that are in blue, we
Mhm.
divide it by 0.01.
Yes, ma'am.
Okay. Hold on. 0.01. I have 0.306.
Yes.
Yay.
That's what I have gotten as well.
Woo.
Woohoo.
Kayla, it's so funny because it's like before when you were like the last person giving your answer because the calculations, now you're the first person.
See?
I'm just so proud of you.
Thank you. Quarantine
The
is really
growth.
just boosting my
Yeah, boosting your
additional
skills.
bandwidth.
The only reason I'm not giving answers is because my pencil rolled underneath my couch. So
Oh, sure. Okay.
Let me have my moment, please. Thanks.
Really? Okay.
I know
So
it's
then it says,
that.
all right, we're moving on. So now there's a
Ooh.
chunk of text before the next question. It says to deliver the 10 milliliter sample of Fe2 plus solution, the student has the choice of using one of the pieces of glassware below. So this is what we're talking about when they say like a lab focused question, right? Like this is in actual reality. If I needed 10 milliliters of something, I have those pieces of equipment. Before even looking at the question, if you need an actual volume, which of those pieces of equipment can never be used for actual volume?
Beaker.
Beaker.
Beaker is for holding only.
Holding only.
All right, you are only going to hold stuff. So beakers and flasks are just for holding liquids. They're not for measuring. So the other 3 pieces of equipment are for measuring, but for measuring things in different situations. So the question says, explain why the 25 milliliter volumetric flask would be a poor choice for delivering the required volume of the iron 2+ solution. And they did specify that word required solution. What is the required volume of that solution?
10 milliliters.
10 milliliters.
Oh, because volumetric flasks, aren't they only marked at what they're labeled?
Yes. And that is the answer.
It only has a 25 milliliter marking.
Mm-hmm.
So you will be guessing.
Yep. Right. So in theory, you could use either a burette or a graduated cylinder, either one, but you could not use a volumetric flask because this would be for exact 25 milliliters only. Right. So these 2 could be used for anything from 0 to 25 milliliters. But a volumetric flask is only for what it's technically marked for, precisely. Okay. And then they switch again with another chunk of text. This, I think, is the most annoying part of the new testing format over the last 4 years. Is like they just chunks of text and then questions and chunks of text and then question. It makes it a very wordy test now. But anyway, it says in a separate experiment, the student is given a sample of powdered iron that contains an impurity. The student uses a procedure to oxidize the iron in the sample to this. All right, so oxidize it to that. The student collects the following data. Mass of iron with inert impurity. So this would be impure iron. And this would be the mass of iron 3 oxide produced there. So G, in theory, should be an easy point to get. Calculate the number of moles of iron in the iron oxide. So what number do you have to start with to start your solution for G?
7.513.
Yeah, good job.
531.
Uh-huh. So what would go in my denominator here?
Molar mass.
The molar mass of this guy, which I have actually memorized over the years, 159.70. And then what's the last step?
You gotta separate the iron to get it by itself. So you put, whoa,
Yeah, you are
something
correct.
moles at the bottom.
So how many moles of what thing in the denominator?
2 moles of iron.
No.
Oh wait, 1
There's
mole.
no Miss Bastion. I'm confused because there's no.
3.
1 mole Fe2O3.
Yes, 1 mole. Oops. Yes. 1 mole Fe2O3, and then the numerator now.
2 moles.
5.
Yeah, Carl's right.
Bastion, I don't understand why.
Yeah, I don't know what the hell.
Okay.
There's no number. There's no mole ratio.
Sure there is. There are 2 places to get a mole ratio. The first mole ratio I taught you how to get was out of the balanced, or was out of the chemical formula. The second mole ratio I taught you how to get was out of the balanced chemical equation. We just happened to use the second one more, but the first one I taught you was that in 1 Fe2O3, there are 2 Fe's. In 1 Fe2O3, there are 3 O's. Don't forget
Wait
the
a
simple one.
Wait a
Oh,
second. Sometimes I feel like there are things in this class that are too easy. But I'm not gonna look a gift horse in the mouth. But I just
Right.
that seems a little easy.
So here, the mole ratio are literally the subscripts in the formula. So how many sig figs in this answer for the moles?
3.
4.
4, because this number is 4. And that's your only given here. So to 4 sig figs, what do we get?
Hold on.
Point. Oh wait, Kayla.
Go ahead, Sean. Bust it down.
Yes, ma'am. 0.0943. 1.
3, 1, yeah. Don't forget that 0.
Yeah, it's placeholder. I had to think about it.
Placeholder.
I was like,
yeah.
Wait, 1. Yes.
Yes. Okay. So that's G. Scooch up just a little bit. Okay. H says calculate the percent by mass of iron in the original sample with the impurity. All right. Percent, you always think part over whole. So even if you don't remember this, what do you think is the part and what do you think is the whole here?
The part is the iron and the whole is the Fe2O3.
And this is not the Fe2O3.
Oh.
It's the impure sample.
Mm-hmm.
So one of those numbers they gave you. Which one?
The impurity.
I have the impurity.
6.7.
And can't we use the moles we just found to find the
Yes, we can. So what do I need to do with this number?
get you a good old molar mass?
Molar mass of iron, which is 55.85. So how many grams of just iron then do we have?
Hold on. 5.267.
Yes. And then it's a percent, so we're going to multiply it by 100. So how many digits should your percentage have?
4?
4. All right, so go ahead and figure out how pure that sample was.
It was C plus at best.
Yes, because the percentage is what?
Wait, I just 78.33.
78.33.
I tickle myself.
Okay, and then the last question says, if the oxidation of the iron in the sample was incomplete, so that some of the product was FeO instead of Fe2O3, would the calculated mass percent of Fe in the original sample be higher, lower, or the same as the mass percent of the iron? This is a question that is like, you know what? This is a question that is designed to separate 4s from 5s, because at this point in the test, right, this is at the end of your third long question on a normal test. They're like, oh, your brain's starting to leak out your ears? Cool. So let's throw this like really weird question in where you have to like actually think through all of these logical lab steps and see what you do with that. And a lot of people said, yeah, that's cool. I'll come back to that if I have time. And that's what the point, that is what that question is designed for. It's fine.
Girl, this is hell.
So what you have to think is you actually have to step through this logically. And it's annoying, but that's how these work. So let's think through logically what they're telling me. So if I have some Fe instead of Fe2O3, it wants to know the mass percent of this. Would it be higher, lower, or the same? So first off, between FeO and Fe2O3, at no point did it technically ask you for the mass percent of iron, right? They haven't actually asked for that, but to be able to answer that question, you kind of have to know that. So the mass percent, let's see here. We already said that the molar mass of this was 159.70. So 2 times 55.85. So that mass percent would be 69.94% iron. FeO, that molar mass is 71.85. And it's 55.85 over that times 100. So it's 77.73%. Okay. So now that you kind of have that, the question wants to know, with the calculated mass percent of the original iron sample, so do you think it would be higher, lower, or the same as what we got up here?
Wait a second. Wait a second. Hold on, Miss Beth.
Uh-huh.
So you're saying, so I'm still trying to get my head around what it's, so it's saying in this situation, if the reaction was, I'm sorry to hear my dog in the background, he barking.
No,
so we're saying that like with the FeO that we found, that percent, are we predicting whether or not it'll be greater or less than or equal to what we found in H?
So what it's saying is, instead of making nothing but Fe2O3, what if up here in this data table you had FeO and Fe2O3?
Okay.
Was both in this mixture.
Mm-hmm.
What do you think that means for if you had some FEO in there and did not realize it? What would that mean? So like if you, it's going to affect it in several ways. Like if I look at this right here, what would be the mole ratio of FE and FEO?
It'd be 3.
1 to 1.
It would be 1 to 1.
Oh, because now
Right?
it's all, yeah.
So it would be 1 FE over 1 FEO. And what would that mean for this mole amount? Would this mole amount here be larger or smaller?
Smaller.
Smaller,
Mhm.
right?
So that would be smaller.
It would be a smaller mole amount with some FEO. And if you have a smaller mole amount there, what does that mean for this?
It's smaller too.
Smaller too.
Yep. Percent mass.
So then what does that mean for this?
Percent mass.
Everything is just smaller.
Everything is smaller. Everything is smaller. You know what you're going to do next Thursday if you have a question like this?
Where?
You're gonna skip it, and that's okay.
And that's okay.
No,
That
because
is
what
okay.
they've already said, well, they have not produced any questions for AP Chemistry for us to look at. They have already said that they have intentionally put more parts on the question than they actually think you will be able to do in the required time. So what that means is if there's a question like that in the middle of the question, you are not going to waste your time trying to think through that if it is not obvious where to start to begin with. You are going to skip
Trust
it
me, I won't.
and go on and try and get the points you can. Remember, the whole goal on these AP tests is to get all the points you can. It is not to get everything correct. That is never the goal. The goal is to get all the points you can. And if you waste
Get all
your
your
time
points.
on a part of a question that is taking you too long, then you are missing out on points that you can get.
Don't waste your minutes.
Do not waste your minutes.
Mhm.
Okay, so that's the end of this question. That's the end of my Unit 4 questions. So as I said in the email I sent yesterday, it was Units 1, 2, 3, and 4. That was the really old stuff. So that's where my review was going to be focused. Units 5, 6, and 7 are all stuff we did this year. So I have created the checklists so that you can look and see, it's like, what were those topics again? Then I also loaded in the review presentations, links to the AP College Board produced review videos. All that sort of stuff is in there at the bottom of the weekly plan. You should go through some of that stuff to refresh your memory, hands down. And then on Wednesday, we're going to do two things. Thing number one is we are going to go over the actual day of test. They have made a demo portal live for us to play with. And we're going to have to talk through technology in terms of what kinds of computers, tablets, phones people have, whether or not people want to type versus handwrite, and how we are going to submit your answers. And there is no one size fits all here, so we're just going to talk through all the possibilities. And the entire point of the demo website that they've created is for you to try out different possibilities of submitting answers with the equipment and the Wi-Fi that you have to see what works best. Okay, so we're going to do that on Wednesday. That's the main focus. And then we're also going to annotate the formula sheet and your periodic table, because if you get to have those things, then we should put more information on them to make them more useful. So there's that. I included links on the weekly plan to PDF versions if you want to print off fresh copies of those. If not, then you can just annotate what you've got. And then on Friday, we are going to do a good portion of last year's free response questions. And then next week, we are going to do some model questions that AP teachers have come up with. And that's it.
Woo!
Woo!
Long live my brain.
Yeah.
So let me just ask, yeah.
Yes.
So these AP, like none of them are longer than like 50 minutes, right?
The test? Correct.
Yeah, the actual test. Okay.
Yeah. Yep.
And to your knowledge, 'cause I can't remember off the top of my head, there are none that are scheduled for the same day. At least the
Don't
ones that like
believe-
we offer at.
I don't believe any of ours conflict. No, but I will double check the schedule later today to see when the AP Lang, the A Push. Anybody in here in music theory? AP Music Theory? Jackson, are you?
Nope.
Nope. Okay. So yeah, so I'll see when those are. And
Wait, all AP English, all AP Lang, whatever English things are the same day, right? No matter what grade you're in, right?
that I don't remember because I wasn't paying attention. So I'll look and see because yeah.
I was just asking because I was gonna say if that's the case, then I know they're definitely not on the same day because it's saying on College Board.
Yeah, that's what I was saying. So we've got yeah, seniors and then AP Calc. I need to see when that one is, but yeah. So AP Lit.
AP Calc's the Tuesday before the chemistry test.
Okay. Yeah.
As well. And the AP US History is the 15th.
Okay, it's the day after. Yeah, and I think all of our tests are at 2. I don't know when human geography is. I know there's a few of you in that one, but
Whew.
so
Oh. Whew.
yeah. All right. So unless anybody's got any specific questions, just keep working through personal progress checks and that sort of stuff. And that be it.
Thank
All
you.
right.
Okay, bye.
Bye.
Bye. Bye.